Hello guys, today I want to show you how you can solve this problem. So basically we need to show that f prime evaluated at x equals a is going to be equal to g evaluated at x equals a if f of x is equal to x minus a times g of x. You can see that g of x is any function, and we need to show that using the definition, okay, the derivative definition. So let's begin, okay? It is a pretty cool problem because we need to do something kind of tricky, at the middle of the entire process, but then things get pretty easy, okay? So yeah, let me show you. We know that first, if we want to find f prime, we can, we need to use the derivative definition. So we know that f prime of x is going to be the limit as h approaches 0 in the function x plus h minus a times g of x plus h minus the initial value, so we have x minus a times g of x, okay? And all this thing divided h. Nice. Now, what we're going to do is the following, and here's where things get a bit tricky. So now, I'm not going to continue on this side because I'm actually not going to have a space. So yeah, I'm going to continue down here. I'll use that space later on. So we know this will be equal to the limit as h approaches 0 for, now watch this. I'm going to write the first term that we have, which is going to be the functions with the plus h. So minus a times g of x plus h. Now, watch what I'm going to do. I'm going to do it, and I'm going to explain why I did it after I'm done doing it. So it's going to go like this. It should be plus g of x times x plus h minus a minus g of x times x plus h minus a. And now, the last term. So we have minus x minus a times g of x, okay? And this whole thing divided by h, okay? It is very hard to make a straight line that long, but well, I tried my best. So yeah, now you might be wondering, well, what happened? And what happened is this. So I wrote the first term that we have, which is this one in here. You can see it, nothing new changed. But in the middle, I wrote two new terms, which are these two, okay? Now first, you can see that these two terms, they do not change the initial limit that we had at the beginning because they are the same term but with opposite signs, okay? So they just cancel out each other and they're just zero. They won't do anything, okay? Now, if they don't do anything, then why did I write them? Well, turns out that when you have two functions that have an x in them, that is when you have two functions multiplying each other, well, you can use the product rule, but in this case, we cannot. The only thing that we can do is we should be able to factor out things so that we can get the derivative for any function, be it g or be it x minus a, okay? So I'm going to show you what I mean by factoring out so that we can get derivatives. Let me show you what I mean by that. So this is going to be equal to, I'm going to continue over here again, and this should be, I'm going to do it a bit more below, or maybe I will, probably like over here. So we have the limit as h approaches 0. Now, how can we write the derivative of g? Let's pick g. Can we pick g? Yeah, we can. So how can we write the derivative of g using these two terms, these two new blue terms? So you can see that in this term, which is minus g times x plus h minus a, you can see that over here, well, we have x plus h minus a, and also we have x plus h minus a on this term over here. So we can factor out x plus h minus a. So we have x plus h minus a, and this would be times, I'm actually going to do it like this. So times g of x plus h, which is this one, okay, minus this one over here, okay? The minus comes from this negative one that you have in here. We just took out this x plus h minus a. So we have minus g of x, okay? And now, what we can do is, okay, this is the first factoring that we need to do. Now the second factoring, these two terms, okay, this one, don't see it anymore, we just used it. This one, we also used it. Now what can we do with these two terms? You can see that they share another common factor, which is g of x. So once again, we can take out g of x from those two terms. Let me make this h smaller so that we have more space. So this is going to be plus g of x, and now we go once again times, we go once again times x plus h minus a, and now minus this one, we just This g of x comes from this term, I'm sorry, the positive one. And now we're taking the g out of this term, the one with the negative sign. So you have minus x minus a, okay? And this entire thing divided by h, okay? Nice. Now, I hope that you're following what I'm doing. This is basically just algebra. This is pure algebra. You need to understand that you can write two things that won't do anything to the original limit, but however, they are very easy. They will allow you to do something pretty interesting, which is factor out things and now get derivatives. And what I mean by get derivatives is the following. So you can write, once again, this is going to be the limit as h approaches 0 for, now watch this. You have x plus h minus a times, now since you have two limits, you can see it, you have two limits, so what you can do is you can distribute this h into those two limits or terms. So you have g of x plus h minus g of x over h, okay? And now you see what I'm doing, plus the limit as h approaches 0 for, now we have this. So we have g of x times, now actually this is a derivative. The function that you have is x minus a, because you can see that when you distribute h as a denominator to these two terms, well, you're gonna get the derivative of x minus a. But something we can do is the following. We know this is gonna be minus x plus a, okay, this term over here. And you can see that this x, it will cancel out with this negative one, and this minus a will cancel out with this positive a. So you're just gonna get h out there. So you have h over h. And that is really cool. Why did I make this parenthesis so big? Yeah. And that is really cool because now we don't have to worry about dividing by 0 anymore, okay? Nowhere in this expression we have a division by 0. So over here we have x plus, once again, the limit as h approaches 0 for x plus h minus a times g prime. Okay, now you can write it like that. G prime, because this is the derivative of, this is the derivative of g. This h over h, it is going to be 1. And the limit of g of x, that is just simply going to be plus g of x, okay? We don't have any h terms in there, so there's nothing, this limit does nothing to g of x. Now we have this, and now you can find finally that limit. So let's do it over here. We know finally that this limit, we only have this h, and this h is going to 0, so it does nothing. So we just get that the derivative will be x minus a, that's g, I'm sorry, x minus a, times g prime, this is g, times g prime plus g of x, okay? This is how much we get. And we could, this is, of course, this is going to be f prime of x, okay? Now, I'm going to erase, I'm probably going to erase this over here. Let me erase this over here. Yep. So now we know that we know that f prime of x is going to be equal to this expression, okay? That is the derivative of f. Now we need to show that f prime evaluated at a is equal to g of a. So first, we know that g of a is going to be equal to, so g of a, oh no, actually we can't do that because we don't know how g of x is defined. But what we can do is begin with the derivative. So we can say that f prime of a is going to be equal to, so you have a minus a times g prime of a plus g of a, and now you probably see that we just showed what we wanted to show. This will be equal to 0, okay? So you're going to have f prime of a, oh, that should be like a, that should have been a parenthesis, but I wrote like a, like apostrophe parenthesis, like a combination of the two, I'm sorry. F prime a is equal to 0, this term, it goes out, and now you have g of a, okay? And this is what we wanted to show, okay? We got the derivative of f using the derivative definition, and now we evaluated that derivative at x equals 0, x equals a, I'm sorry. And well, you can see that this term, it cancels out because you get a minus a, that's 0. And you have g of x as the second term for your derivative. And when you plug in a, for x, well, you get g of a, okay? And well, we just solved this problem, okay? So I hope you enjoyed this video, you learned something. This technique, I don't know how the technique of writing new terms and factoring out so you can get derivatives is called. I don't know how that technique is called, but it is very useful if you're finding limits using the quotient, when you need to find the limit or the derivative of when you have the product of two functions, basically, okay? When you have in the quotient two functions multiplying each other, you are probably gonna have to you must use that technique, okay? And if you can master it, well, that is gonna be very helpful. So yep, this is everything. I hope you enjoyed this video and see you in the following one. Bye.